So today we're going to pick up with branch-chained alkanes, and so you did some practice last night over the, when you were given a compound trying to name it, and now this is kind of working in reverse. They've given you the name and they want you to draw it. These are actually easier because you can start, there's no question about where the main chain is because they've given you the last name, so we know that this is a 1, 2, 3, 4, 5 carbon alkane, and then coming off of the third carbon, which it doesn't matter which way we number it, we have an ethyl group, and so that'll be our ethyl branch. So then we could fill in CH3, this one is CH2, this one's just CH, CH2, CH3, CH2, and CH3 to satisfy the octet for the carbon. This next one is also pentane, so we'll draw 5 going across. Coming off the second carbon, we have a methyl group, so that's a 1 carbon, CH3. And coming up off the top, we have another CH3. Coming off the fourth carbon, we have our last CH3. And Sullivan's trying to get in on the action. He's trying to say cat, because the cat's walking around the TV room right now. All right, they give you a challenge here, and what's happening is you have a branch off of a branch, which is a little strange. And these actually are usually given special names when this happens. We'll draw it out just using the name that they've given us. So decane is where we'll begin. So that's a 10 carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's our 10. So coming off the second carbon and the third carbon, we've got a methyl group. So there's our CH3, CH3. And then coming off of the sixth carbon, we've got this methyl propyl group. So if we number this, just to keep track, we've got 2, 3, 4, 5, and 6. So coming off of here, the last name for the 6 is propyl, which means we've got a meth, F, prop. And then coming off of that second carbon is where this methyl comes in. So then you see you've got a branch off of a branch. And so if we go and we fill in our H's, we've got CH3, CH2, 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 CH, CH2, CH3, CH2, CH2, a CH, a CH, and a CH3. So that wraps up our branch-chained alkanes. We're going to move on now to our cyclic alkanes. And those, kind of like the name implies, is basically an alkane that wraps up, and you can think of it as the hydrogens popping off the end, and then the carbons are going to bond with one another. So the general formula for a cyclic alkane is you double the number of carbons to get the hydrogen. We don't have that +2 anymore, because if they're joining at the ends, those hydrogens have to pop off so they can link up. So this is where you start to see all these cute little shapes popping up, and they really do stand for compounds. So the simplest cyclic alkane that we have is cyclopropane, and prop, hopefully you're learning those prefixes, what they mean, is 3, and instead of doubling it and adding 2, we're just going to double it. So the triangle is used to represent cyclopropane, because at the end of each line you've got a carbon, and so you've got the equilateral triangle here. They don't overlap head-on, but they still do have the sp3 hybridization. So if you think about, each of these has basically 2 hydrogens coming off, and then you've got your carbons there. The next is cyclobutane, so that would be C4H8. Again, 1, 2, 3, 4 makes a square. You've got cyclopentane, which looks like a pentagon, C5H10, and then cyclohexane, C6H12. And so that's our hexagon. Now, of course, to make these more interesting, you can have branches off of these. So sometimes they'll show it as a picture, like if you notice in A, they've got the triangle, but they're also showing you how many H's there are. So that's a little bit less condensed than, say, this form that just has the shape. So this is just going to be called cyclo and meth-eth-prop. So cyclopropane. All right, moving down to B. The shape is a pentagon, so we know this is a form of cyclopentane. And then you'll notice these little lines coming off. And so yesterday we talked about the fact that at the end of each line there's a carbon. So this is a 1-carbon branch. This is a 1-carbon branch. We need to number the carbon just like we did with our straight and branch chain to let people know where these are coming off. So these are methyl groups. If I number going this way, so if I say 1, then 2, then 3, and then 4, I have a 1-4 number combination. If I go the other way, if I say 1, 2, 3, 4, 5, if I go that way, now I have a 1, 3 dimethyl cyclopentane. So again, you're wanting to get the lowest number possible, and so that's why we number it going clockwise. And you could certainly start here and go 1, 2, 3, and you get the same name. All right, in C we see a square, so we know that the base is cyclobutane, and then again a 1-carbon branch, a 1-carbon branch, doesn't matter which way we number, that's going to be a 1, 3 dimethyl cyclobutane. Going up to D, we've got a shape 1, 2, 3, 4, 5, 6. So this is cyclohexane, and coming off of this one, we have 2 methyl groups. It's coming off the same carbon, so we just say 1, 1 dimethyl cyclohexane. 1, 1 dimethyl cyclohexane. All right, here we've got cyclohexane again, but count your carbons on the branch. We got 1, 2, 3. This carbon is already on the cyclohexane part. So we've got cyclohexane as our ending, and then we've got a 3-carbon branch, so that's meth-eth-prop. So we've got propyl cyclohexane. Now there's no other branches, and so we could certainly say 1 propyl cyclohexane, but since there's no other branches, we can really do without the number. It wouldn't be wrong to include it. All right, our last one, we've got a triangle, a branch, and a branch. The triangle represents cyclometh-eth-propane. Cyclopropane. So coming off, we've got methyl groups. If I number going this way, 1, 2, 3, that gives me a 1, 3 dimethyl. So that's not going to work. We're going to go the other way. 1, 2, 3. So we have a 1, 2 dimethyl cyclopropane. So that's how you do your cyclics. To continue the fun, we can have what are called halogenated alkanes, and like it sounds, you've got a halogen that's attached to an alkane. So what we do is if we have something like chlorine, chlorine as a branch becomes chloro. If you have fluorine, it becomes fluoro. If you have bromine, it becomes bromo. If you have iodine, it becomes iodo. Yes, it really is iodo. All right, so if we look at these, we've got down here, this is just a 1-carbon, so we know that it's methane, but we have this guy on here instead of a hydrogen. So this is called chloromethane. So that would be a halogenated alkane and how you name it. All right, here we got a lot going on. We've still got 1 carbon, still going to end in methane, but we've got a chlorine, and a chlorine. So that's going to be trichloro. And then we've got this guy, fluorine, to be fluoro. We don't need any numbers, but we do need to let them know how many. So we have trichloro, fluoro, finally methane. And we do the chlorine before the fluorine, just alphabetically. So the chlorine gets named before the fluorine. All right, moving down to C, we've got a 2-carbon alkane. We know it's an alkane because we got that single bond there. We've got a bromine. So we know we have ethane, and then coming off of one of the carbons, we have a bromine. So we're not going to call it bromine ethane. We're going to call it bromoethane. When we think about numbering, I could number it. I could say that it's 1 bromoethane, but that's the only form of ethane that, for this that exists. Oops, sorry, didn't mean to turn the screen on you. So 1 is a little redundant, so you really don't need the 1. All right, D, we've got a 3-carbon alkane, so meth-F-prop, so the last name will be propane. Coming off of the 2nd carbon, we have a bromine. Bromine becomes bromo, so this would be 2-bromo-propane. All right, back up to E. Now we've got line notation. You got to be a little careful, and the good news is College Board does not really use line notation. You see these F's, they're kind of showing it as like a bond, so it can be a little confusing. There's 3 carbons on the chain, so a 3-carbon is propane. And then coming off these guys, this first carbon, we have 2 fluorines. And then coming off the last carbon, we have 1 fluorine. So altogether, we have trifluoropropane. And to let people know where it's happening, we would say 1, 1, 3. Trifluoropropane. We could number from the right to the left, so we'd call it 1, 3, 3 trifluoro, but again, we're trying to get that lowest number combination, so that's why this one works. All right, another one on line notation. So for this one, it's kind of hard to tell, is that a bond, or are they showing the bromine coming off? We'll assume that they're not showing it as a line there, so this would be meth-F-prop-butane. And coming off of the end, we have a 1-bromobutane. All right, and in this one, these last 2, they give you a condensed version. So you just kind of really have to look out for your carbon. So we've got a carbon there and a carbon there. And then these guys are coming off this carbon, and these guys are coming off this carbon. So total, we have 2 carbons. So this is ethane. And we've got chlorine coming off of 1 and fluorine coming off of 1. We could number left to right or right to left. Let's give chlorine the lower number. So we would say 1 chloro, he gets named first, and then 2 fluoroethane. All right, and then the last one, here we've got a carbon, and a carbon. And I know it's kind of tricky because you see that C, but that's a Cl, so there's 2 chlorines. And then we've got a carbon, 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 no other branches. So meth-F-prop, so this is propane, and coming off the first carbon, we would say 1-chloropropane. So that's going to do it for our halogenated alkanes. Additional practice listed, try 22.37 as well as 22.30 and see how those go. And we will go over those the next day in class.